In this lesson, we'll continue our discussion on big idea number 1. What are equilibria and how can they be quantitatively described? And we'll finish off learning target number 9. By the end of this lesson, you should be able to predict if a precipitate will form in a double displacement reaction. In order to see a precipitate form in a double displacement reaction, two conditions must be met. First, you need to create an insoluble product as predicted by the solubility table. Secondly, you also need to have high enough ion concentrations to max out the solubility of the insoluble chemical so that the solubility equilibrium is forced to move to the left, making visible solid. Remember that reaction quotients, or Q's, are expressions calculated the same as equilibrium constants, K's. But use concentrations that you know may not be at equilibrium. You can predict if a precipitate will be formed by determining the KSP of a solubility equilibrium created by the double displacement reaction and compare it to the accepted KSP. In order to calculate a QSP, you take the concentration of the products and raise them to their coefficients. If Q is greater than K, it means that the system has reached saturation and contains excess ions. The reverse reaction will go faster to reach equilibrium, producing a visible precipitate. If Q is equal to K, it means that the system is at equilibrium and the solution has just reached its saturation point, so you will not see a precipitate form. And if Q is less than K, the system has not yet reached saturation. The forward reaction will go faster to reach equilibrium, and any solid made will dissolve again, so no precipitate will be seen. Let's look at an example. Here we're going to mix sodium chloride and silver nitrate together, and the question asks us, will a precipitate form? Let's see if it meets our first condition. We'll start by writing a balanced chemical equation. This will be a double displacement reaction, forming sodium nitrate, which is predicted as being aqueous on our solubility table, and silver chloride, which is being predicted as a solid on our solubility table. So will a precipitate form? Maybe, if we have enough silver and chlorine ions present in our system. Let's figure out what their concentrations will be using stoichiometry. We have a 1 mole per liter sodium chloride solution, and we're going to use our tiny drop, 0.0020 liters. We have a 0.1 mole per liter silver nitrate solution, and we're going to use 50 mils, or 0.05 liters. To find the concentration of the chlorine and the silver ions present, we could take the concentration times the volume to get the moles of chlorine, because 1 chlorine is generated for every 1 NaCl. And then we could divide that by the volume in our system. It would be 50 mils plus 0.2 mils. Or we could view this as just a straight dilution. I'm taking two solutions and I'm mixing them together. What would the concentration of each ion be before they reacted? So you can use C1V1 equals C2V2 and use V2 equaling the combined volumes of the solutions, or 50.2 mils. To see if there's a precipitate made, we need to look at the solubility equilibrium of our insoluble product, silver chloride. If we write an equation showing it dissolving and calculate a Q, we can compare it to see if we're at equilibrium or which direction the reaction will shift. Using C1V1 equals C2V2, the concentration of the silver will be 0.0996 moles per liter, and the concentration of the chlorine will be 3.98 times 10 to the minus 5 moles per liter. I'm calling this a QSP because I'm not sure if these are concentrations at equilibrium. Now I compare my Q answer to the KSP that's given in the question. Since my Q is larger in value than K, it means that the reverse reaction will go faster and I will make visible precipitate. Pause the video here and predict if a precipitate will form in example 2. Start the video again when you have your prediction. Here's the answer for example 2. Let's start by writing a balanced chemical equation. This will make PbI2, which my solubility table predicts as being a solid, if I have the right ion concentrations, and sodium nitrate, which will be an AQ. Let's now look up the KSP of our insoluble product, PbI2. In Appendix B, it's listed as 9.8 times 10 to the minus 9. I need to now find the concentrations of the lead and the iodine that's going to be present in my system. I can use C1V1 equals C2V2 in order to do that. And I use the combined volume of 500 mils. This will tell me what the concentration of the lead and the iodine will be once they've been mixed together but still haven't reacted yet. If I take the concentration of the lead nitrate, because lead nitrate gives me 1 lead, and times it by the volume, and sub that in for C1 and V1, and find C2, then I get a lead concentration of 0.208 mole per liter. I would then do the same thing to find the concentration of the iodine. Every sodium iodide gives me 1 iodine. Then sub this into a QSP expression. Since my Q is bigger than the accepted K value for PBI2, then a precipitate will form.